Okay, again, section 3.3, this is number 38. And what we want to do is we want to find the tangent of the curve, y equals x cubed plus x, at the points where the slope is 4. So we know the slope is 4, so we're going to find out the tangent lines, actually the equation of the tangent lines. When the slope is 4, what's the smallest slope of the curve, and at what value of x does the curve have this slope? So first of all, if we know that the slope is 4, we know the derivative will be equal to 4. So we can take the derivative, which is the slope. And the derivative of y as a function of x is y prime as a function of x, which is just 3x squared plus 1 equals 4. Then I can subtract 1 from both sides, so I get 3x squared equals 3, x squared equals 1, so x equals plus or minus 1. So those are the two x values where the derivative equals 4 or the slope equals 4. I can put those x values back in the original equation to find the y value, so I have my points of tangency. All right, my points of tangency would be when x is 1, y of 1, or this equation, the original equation of 1, evaluated 1 is 1 cubed plus 1, which is 2. So one point of tangency is 1, 2. And then if I put negative 1 in here, if I have negative 1 cubed plus negative 1, and that happens to be negative 1 and negative 1, which is negative 2. So when x is negative 2, my y value would be negative 2. So that's my other point of tangency. So I've got 2 points of tangency. So I would have 2 tangent lines. Remember, the slope's going to be 4 for both those. If you graph this, if you graph this equation, you see how that works. It's a cubic with a little shift on it, so you can kind of figure that out, and you'll see what's happening. Why you would have 2 points where the slope is 4. So if we want to find the equation of the lines, we just put those points in our point-slope form. We have the point and the slope, so we have m is 4 in both cases. M is 4. I've got 1 point, 1, 2, so if I put this in the point-slope form, y minus y1 equals m times x minus x1. Then we simplify that out. 4x minus 4, if I add 2 to both sides, 2. Simplify these, y equals 4x minus 2. That's one tangent line, so that's the line that's tangent to the curve at this point of tangency 1, 2. And at this point of tangency, the tangent line, again, would be y, and I use the point-slope form, y minus negative 2, there's my y1, equals m, 4, times x minus, and this would be negative 1. So it becomes y plus 2, 4 times x plus 1, and then I would subtract 2 from both sides. 4 times x is 4x plus 4 minus 2, which is 4x plus 2. So that's my other tangent line. So those are the 2 tangent lines. That's the answer to one part of the problem. The next part, where is the smallest slope of the curve? Or what is the small slope of the curve? Okay, and what value of x does the curve have the slope? Well, I actually found that first. And I just looked at my slope, and I noticed it's a parabola. It's positive, so it's shaped like a U, so I know it has a minimum value at the vertex. So if I just sketch this parabola, it's just going to be stretched out, or a little skinnier, as I would say, 3 times x squared rather than a standard x squared parabola, so it's a little skinnier. And it's not shifted left or right, but it's just shifted up. So that's going to be where the vertex is. This is about what it would look like. So I will have a minimum value when x is 0. So a minimum value when x is 0, so I can put that 0 value into the equation of the slope, which is the derivative, 3x squared plus 1. And 3 times 0 squared plus 1 is just 3 times 0, which is just 0 plus 1 is 1. So my minimum slope is 1, and it occurs when x equals 0. So I hope that makes sense.